be better for you to just use the calculator than use that what we're doing today. All right, so as far as that goes, let's get everybody to just shut your computers, get those out of the way, so that way that's not a distraction for you. Okay. So we're in the notes. We've got these exponential problems. We're going to talk about growth and decay, both of which would be in context. In context is a fancy word for word problems. I'll take your headphones up, please. And we learn with systems, right? Word problems aren't very difficult. You just got to find what's important out of the problem. All right, so Casey, close the computer on the way for me. All right, we've got this general formula, right? We know with exponential functions, okay, we talk about this general formula. I don't know why I forget that it's white whenever I start every day, but anyway, we got this general formula that's y is equal to a times b raised to the x power, right? We've talked about that. Okay, we want to talk about really what that b term means, and really all the terms, but what happens to get that b term. Okay, so when we have exponential growth, okay, we're going to have the function, the formula that looks like this: y is equal to a times, okay, and instead of that times, I might just do a parentheses, okay, 1 plus r raised to the t power. Okay, 1 plus r raised to the t power. All right, that a, the variable a, stands for our initial amount. Okay, somebody tell me what initial amount, what's a different way that we can say initial amount? Leftover. Starting, right? Whatever you started with, that would be an amount that you started with. Okay, initial amount would be something that you started with. Okay, that r is going to be your rate. Okay, but if we're talking about exponential growth, right, that's going to be our growth rate. Okay, growth rate. Okay, and then any guesses on what t might be? What is your exponent, but what would t stand for?
No, not decay.
We're talking about growth, but what would t stand for? What's the word that starts with t that you see sometimes in math? There it is, time. Okay, t is going to represent time. T is going to represent time for us. And now that we know what a, r, and t stand for, we can use those things out of a word problem to come up with our equation. We'll evaluate. Okay. So looking at number one, okay, we've got the original value of an investment is $1,400. Okay, the value increases by 9% each year. Use exponential growth function to find the value of the investment after 25 years. Okay, one thing that we do have to know, which is a base skill that you kind of have to know starting out, okay, is how to turn a percent to a decimal. Okay, does anybody remember how to take a percent to a decimal? You can divide, that's one option. Divide by what? 100, right? So one way is take your percent, 9%, and divide by 100, and that would change it to a decimal. Okay? The other way that we could do this and say 9, okay, well 9 has a decimal right here. You can move that decimal 2 spots to the left, right? Move your decimal here, and any open space gets a 0. Okay, so that would be 0.09. Okay, if you divided 9 by 100, you would have also got 0.09. So that's your two ways to change a percent to a decimal. Okay, so we've got 9%, okay, an increased value, which makes sense because we have exponential growth, right? If I had decrease, that would be what? Growth or decay? Decay, right? All right, so the original value, the starting amount, the initial amount. Okay, so we've got y is equal to the original value, which was 1,400. So we're going to plug that in where a goes. So 1,400 times 1 plus my rate. Okay, we said the rate was 9%. Okay, what is that as a decimal? 0.09. Okay, so 0.09, close parentheses. Okay, and then our exponent is t, which is time,
25,
which is 25. So you're going to raise this to the 25th power. Okay, somebody remind me how to put that in the calculator for an exponent.
be if you were squaring something. Okay, that is an exponent, but that's if it's squared. Okay, how do I put any number for the exponent?
Use the arrow.
Use that arrow that's above the division sign. So look, there's that little arrow above the division sign that's gonna give you the exponent. Okay, so when you're on the calculator, this right side here, this 1400 times 1 plus 0.9 raised to the 25th power, type it in exactly like you see it here. Okay, type it in exactly like you see it here. Okay, and when you evaluate that, you type it in exactly how you see it. That's going to tell you y is equal. It's going to tell you what your investment is worth after 25 years. Okay, what do we end up with? Has anybody gotten that far? What do we think? Need a little bit more time, or people just unsure of their answers? What'd you get?
I've got like a really long distance.
What'd y'all get?
120.31292.
All right, yeah, so y'all started off with 12,072, right? Is everybody with me there? Okay, and we're talking about money. So everybody was just unsure of their answer. That's what that was. Okay, but we're talking about money, so we need to round to the hundreds, right? So the first two decimal places. Okay, when you do that, what do you end up with your answer? So we know everybody got this, right? Everybody got the 12,072, so $12,072. Okay, and then when we round to the 100, okay, what do we get? Point what? 31. 0.31. What was that number after, or what was the
292.
let me check, because I don't have it written down. Okay, y'all had 0.312, that 2 is less than 5, so you need to round it down and stay 0.31, right? Everybody knows how to round, feels comfortable with rounding? All right, any questions on number 1? All right, so what was the value of our investment after 25 years? Our $12,072.31, right? We started off with $1,400. After 25 years, now it's worth a little over $12,000. Everybody sees how that works? Okay, that's what the question's asking. All right, number 2, the cost of college tuition at a college is $12,000 and is increasing at a rate of 6% each year. You write an exponential function to find the tuition cost after 4 years. Okay, so what's my initial amount? What's my A? 12,000. 12,000. Okay, that gets multiplied by 1. Okay, we've got growth because it's increasing, right? Okay, so 1 plus, do a better plus. Okay, and then what's my decimal? 0.06. 0.06. Okay, and then after how many years are we evaluating? 4. So it gets raised to the 4th power. Okay, now that on the right side of the equal sign gets plugged in. Okay, remember, we're talking about money, so it needs to be rounded to the 100th place. Whoever that is, please silence it. I've heard it a couple times.
15,149.72.
That's it. Okay, so we got 15,000. 15,000, repeat it for me. 15,000 what?
149.
15,149.72. Okay, so how much is tuition in 4 years? $15,149.72. Okay, any questions there? That had this on it? Yeah, I might have had that on there. Okay, but if you, that's still open until Monday, so if y'all didn't know how to work that yesterday, now you know how to work it, you can go back and do that. Okay, all right, so let's move on. Let's see, what time we got here? 8:53. All right, let's see. Definitely want to do number 6. I don't know, we'll just do all. It's not that many problems. Okay. All right, so the number of student athletes in a local high school is 300 and is increasing at a rate of 8% each year. Use an exponential function to find the number of student athletes after 5 years. Okay, so we got y is equal to, how many student athletes do we start with? 300. Okay, and you have 1 plus your rate, which is what? 0.08. 0.08, and then we're trying to evaluate after how many years? 5, so that's my exponent. Okay, and you're just plugging that in. Alright, so I want you to think about this. Okay, I want you to think about this. Number 3, what are we talking about? What is number 3 asking us about? The number of student athletes. Student athletes are what? What are student athletes? Does anybody play a sport in here? Okay, what are you? You're a person, right? Okay. So a person, can we have a percentage of a person? Can we have 0.72 of a person? Okay, we gotta think about what do we do rounding wise? Can I have 3/4 of a person? No, right? Can I say, well, we've got this 0.7, whatever y'all have as a decimal, can I just make up 20% of a person and then throw it in there? Can I do that? Can I look at LaJalen and say, I want 20% more of LaJalen? Can I do that? No, right? So what do you have to do rounding wise on this? If you can't make up a person to go up, you have to round down.
Nearest 10.
Okay, down to the nearest whole number, because we can't have any decimal of a person, right? So what would be my answer?
440.
440. 440. Right, does everybody understand what I'm saying there? Okay. All right. Number 4, annual sales of the company is $149,999. Okay, it's increasing at a rate of 6%. Okay, we want to find out how much the sales are after 7 years. Okay, so we've got y is equal to my initial amount, which is
149,999.
Okay, times 1 increasing plus my rate, which is 0.06. Raised to the 7th power, because we're looking for 7 years. Okay? So again, we're talking about money now, right? So money gets rounded to the
I don't know. How many?
100, 2 decimal places. Okay? Has anybody gotten that answer yet? What we got? Anybody? What we got is our answer when you plug that in. Okay, and what's my decimal? My decimal.
4 cent.
Huh?
4 cent, cause they got, the 5.
Right, yeah. 0.04. Okay, did everybody get that? Or is people just starting to wait on somebody else to answer? All right, look, we've done a pretty good job so far on answering. There's no reason to believe that I can't solve this problem, right? Not me personally, but y'all can't solve this problem. There's no reason to believe that, okay? Because everybody's done a good job so far. So don't just give me those blank stares like you're waiting on me to help you out. Y'all can do it yourself. Smart enough. All right, any questions on 3 or 4? All right, I'm gonna erase 3 and 4 so that way I can get 6 in the picture. We'll do 5 and 6 at the same time. So any questions there? Okay, let's look at 5 and 6 then. Okay, so the population of a small town is 1,600. Okay, so we've got 1,600 people increasing at a rate of 3% each year. Okay, and use this exponential function. Okay, use this exponential function. So y is equal to my initial amount, which is 1,600. Zay is the only one that knows how to do this. I know that.
Okay, we're increasing at a rate of 3%, so I'm doing plus what?
0.03.
0.03, 0.03, and then raising it to the 10th power, because we're looking after 10 years. Or you might type something in just a hair wrong, right? What'd you type in? Did you type in that?
It's 20.
Hold on a second, what? Oh, yeah, that'll mess you up sometimes, right? All right, so what we end up with? 2,150. Okay, did everybody get that? So what was your decimal on that? Okay, so why did you round down?
Came around the whole.
You can't just make up a person, right? We just talked about that. So you did the right thing by rounding down. Okay, I just wanted to make sure we understood that. I wasn't saying it was wrong. Okay. All right, any questions on 5? All right, number 6. Okay, in 1985, this one's a good one. Okay, so in 1985, there were 285 cell phone subscribers in Mayville. Okay, the number of subscribers increased by 75% per year after 1985. Find the number of subscribers in 2008. All right, so we've got Y equals, how many people were subscribers at the start? 285. 285. Okay, then we know that we're increasing by 75%. So what's my decimal? All right, be careful there, right? A lot of these have been single percentages. Okay, 75%. If we move this decimal place 2 places, what we got? We got 0.75. Right, there wasn't an open spot to throw a 0 in there. Okay, you could have also done a 75 divided by 100, which gave you 0.75. Okay, so that's what we're adding by 0.75. Now, here's the good part about this problem, and why I think it's good is because this is the type of problem that would be set up on the state test. Okay, so look at this. In 1985, we started with this, right? And we want to figure out
Per year.
how many people were in 2008. But we still need to know the time that's passed.
You gonna subtract.
So we need to subtract, right? We got 2008 minus 1985, and we're going to figure out how many years have passed. 23. So what's my exponent? 23. Wasn't too bad, was it?
No.
Feel like you did a harder problem and did good at it? Yes or no? All right. So what do we get? Don't be scared by your long number because it's right. What is it? All right, we start off with 110 million. What else? 845,900 what?
And 88.
Okay.
0.30.
All right, but we're talking about what? We're talking about people, right? Subscribers. Y'all subscribe to something on YouTube, right? You're a person subscribing to that YouTube channel, right? So you can't subscribe a point something of a person.
So the answer to it gonna be like this,
Well, it could be, right? Think about exponential functions. That's a good question. So Jalen asked, will the answers on tests be long answers? And they could be, right? When you think about an exponential function, right, what do we know about an exponential? This isn't the best looking graph. But what do we know about an exponential function, right? It starts off pretty flat, right? And then all of a sudden it does what? It like shoots up. Right? Everybody knows what that looks like? Okay, well what happens when it shoots up? You start increasing really, really fast. Okay? So you could have very big answers depending on what your function looks like. Okay, you could have an answer that ended up here, or you could have an answer that ended up over here. It just depends on what the question's asking. Okay, there's a good question math-wise that involves exponential functions in a real-world sense, okay? I want to go ahead and ask you that today. You can think on it, okay? You can think on it and then give me an answer tomorrow when you come in class. Okay, the question is, would you rather, Adrian, okay, would you rather have $1 million today, okay? I'll pull out my wallet, give you $1 million. Would you rather have $1 million today, okay? Or would you rather have a penny doubled every day for a month? Okay,
Hold on,
Think
say
about that.
Say that last part again.
Or you can either have $1 million today,
Mm-hmm.
or you could have a penny
Double.
doubled every day for a month.
So 2 cents.
So think about that.
Mm-hmm.
Think about that.
Either way it goes, you still gonna be rich.
Think about it. All right. So there's exponential growth.
What? That's a.
Exponential growth.
Well, you ain't getting nothing but like 30 cents. That's 60 cents. I get dollars. A million. Oh, $1.
30 days or 2 pennies, that's 2 times 30.
Y'all thinking of it wrong. Y'all thinking of it wrong. Okay, let's look at it. I'll pause for a second. We'll talk about it.
And they're gonna be like quarter of 2 times.
All right. So you can either have. Let's see. All right. So you can either have $1 million today. Okay, this is today, right? Okay, or you can have a penny doubled each day for a month. Okay. So day one, how much money would you have?
2 cents.
Day one is what? What do you start with? What's the first day? 0.1, 0.01. You have 1 penny, right? You're gonna start off. I'm gonna give you a penny today. Okay. Tomorrow, day 2, I'm giving you what?
What?
2 pennies.
I'm taking
Okay. Day 3,
all I'm getting now.
you would have what?
Point 3. I
You would have 0.04. You would have 4 pennies. Okay. Does everybody see what's happening? Day 4, you would have 0.08, 0.16, 0.32, 0.64, right? Then you get over $1 on that 6th day. Okay, so that's the question that's asked. Would you rather have this or this continue?
I go.
Okay,
I have this.
just think about it.
I'll get the million.
Just think about it, and we'll look at it tomorrow. Okay. All right. So we've talked about growth. Okay. The other part about this is decay. Okay. So if you think about the difference between growth and decay, one increases, right, and the other decreases.
That's good. You can give me like 1 minus.
So instead of having a plus, you would have y is equal to your initial amount, 1 minus r raised to the t. So this stays the same. This is still our initial amount. Still our initial amount. This is still our rate, but now it's our decay rate. And this still remains time. All right. So the population of a town is decreasing at a rate of 1% each year. Okay, in 2000, in the year 2000, there were 1,300 people. Okay, we want to find the population in 2008. So how many people did we start with? 1,300. Okay, we got a decay rate of 1%, so we're going to subtract 0.01. Okay, how many years have passed from 2000 to 2008? 8, right? So that's my exponent. All right, after plugging that in, what do you get? Say it.
1,199.
Okay, what was the decimal there?
156.
Okay, so what we got to think about, you had say again, you have 1,999. Okay, you have 1,900. Is that what you got?
1,100.
100. I was going to say that didn't sound right. All right, so here you got 1,199 point 568. Okay, whatever. All right, look. When we had growth, when we're looking at people, okay, we had to round down because we couldn't make up the rest of the person, right? Okay, but if we have decay, can I just get rid of a person? Yes or no?
No.
Okay, so decay works the opposite of growth, where now you have to round up, okay, to get 1,200 to the nearest whole person on the person. Okay, it's the opposite of growth. Does that make sense? Okay, so here my answer would be 1,200. Same reason, okay, growth you can't just make up a person, decay you can't just get rid of a person. Okay, so it works the opposite direction on decay. All right, number 8, the value of a car is $18,000. Depreciating means what?
Decreasing.
Okay, it means decreasing. When do you usually see the word depreciating? When would you hear the word depreciating? Okay, so when you see the word depreciating, you're either talking about like the value of a car, you're talking about your house, something like that, that your car might lose value over the years, okay, which would be decreasing. Okay, a lot of times they say that if you buy a new car, right, the moment you drive it off the lot, it depreciates by whatever percent. Okay, so you usually see the word depreciate with that sort of stuff. Okay, so here we've got y is equal to 18,000. Okay, then we got 1 minus, because we're depreciating, decreasing, decay, by 12% each year. What's my decimal? 0.12. Okay, and we're wanting to find out after 10 years, what is the value of the car?
When we do 50, 100?
All right, we got 5,013. Okay, 5,013.01. Okay, we're talking about money, so it's need to be to the 100. What was the number after 1? 7. 7 rounds to 2, right? So you should have 0.02. 0.02 because 7 rounds up. All right, any questions on 8? Everybody good? All right, let's look at 9. So a farmer buys a tractor for $50,000. Okay, the tractor depreciates by 10% each year. Use an exponential function to find the value of the tractor after 7 years. Okay, so we've got y. Y is equal to my initial amount, which is 50,000. Okay, we got 1 minus what's my rate? 0.1. Okay, 0.1. It's not necessarily to do 0.10, but if you put the 0 after, it's not going to hurt anything. Okay.
So we can put it in the calculator as 0.2?
You put it in as 0.1 if you want, but yeah, you put it in as 0.10 too, and it's not going to hurt. Okay. And then here is raised to the 7th power. Okay. What is the value of that tractor? $23,914.85. 45? Which I got? 0.85? Yeah, that's right. Yeah. 845, and the 5 after the 4 would round the 4 to a 5. Okay, so you got 0.85. All right, an investment of $8,200. 8,200 would be my initial amount. Okay, loses value at a rate of 2% each year, so minus 0.02. Okay, find the value of the investment after 9 years. Okay, plugging this in. And you end up with what as our value?
0.02?
Yeah, 0.02 is your rate.
Oh. 9. I mean, you already did that.
Yep.
My bad.
6,836.
6,836. 6,836.73.
73.
0.73. Is everybody feeling pretty comfortable with this? Feel good?
Yeah.
All right. So let's look at the last 2 problems here, and then we're going to move it on. Okay. So number 11. Okay. Initial value of a book is $58. Okay. So $58 is my what? Initial amount. 58. Okay. Times 1 minus what?
0.07.
0.07. Okay, this is raised to the 8th power.
Would it be 32?
32 what?
0.5.
Okay, 32.46, right? We're talking about money, so we need the 100. Okay, talking about money, so we need the 100. Okay, but you did round correctly. If you rounded that 6, it would make it to a 5. But, all right, last problem here. The population of a town is decreasing at a rate of 2.5% per year. Okay, you get the population in 2000 was 2,800. The 2,800 is not initial amounts. 2,800. Okay, 1 minus what?
2.5.
All right, look.
2.5.
You got 2.5%. Okay, everybody look here.
0.025.
Okay, you move this left 2 spots, put your decimal here, and you have 0.025. Okay, so minus 0.025 raised to the 15th power, right? Because from 2000 to 2015, we have passed 15 years. Okay, so what do we end up with for my town population?
19,152 and 50 cents.
Okay,
Wow.
talking about people. Can't have decimal there. All right. One question that needs to be brought up before we just completely stop on the lesson. Okay, think about this time. Okay, so think about the time. If we had something that was talking about find value after 2 years. Okay, 2 years is the same as, what's another way to represent 2 years? How many months? 24 months, right? Okay, so that is potentially something that you might see where you have to take something from months, say, well, it gave me 24 months, I might need to look at it in years. Okay, so you need to be able to do that too. I'm not sure that Khan Academy will do that, okay, but that is a possibility. Speaking of Khan Academy, you got 3 assignments today. You had a go formative yesterday and 3 assignments the day before, so you got 7 total. Okay, let's make sure that we have all those done. Okay. Did I mention to y'all about the benchmark test yet? No. All right. So this exponential unit will finish. It's a short unit. Okay. So I'm going to be finished with this exponential unit probably by Tuesday. Probably by Tuesday. Which means that the way this works, okay, instead of having an exponential unit test, we have to take our first benchmark test in this class.